All right, let's jump right into this explainer. Today, we're looking at the incredibly high stakes of designing for extreme landscapes. We're talking about wildland-urban interfaces, steep, arid slopes, and fire-prone Mediterranean climates that literally test the absolute limits of our built environment. For the longest time, traditional architecture and agriculture have just tried to impose these rigid, sterile, cookie-cutter grids onto wildly dynamic spaces. And, well, as we've seen, that approach often ends in catastrophic failure. So today, we're exploring a completely different paradigm, one that uses spatial design, hydrological engineering, and socio-ecological scaling to build true, lasting resilience.
The absolute crucial point here is that we just cannot fight these massive elemental forces. I mean, you can't simply build a wall strong enough to stop a wildfire or a flash flood if you're completely ignoring the landscape's underlying topography, right? But we can intelligently design our systems to harmonize with them. It's a lot like Aikido, not boxing. We want to take the wild, chaotic energy of the natural world and carefully redirect it so that our landscapes actually thrive under that pressure, rather than collapsing completely beneath it.
And the results of this methodology? They are completely undeniable. When these landscape principles are applied, designers are consistently seeing a 20 to 70% higher yield output compared to your standard conventional monocultures. But honestly, what's even more impressive to me is the hydrological efficiency. Get this, by using these integrated designs, we gain the unbelievable ability to capture over 600 gallons of water per inch of rain on just a single small roof footprint. That's a massive reduction in input costs while simultaneously building deep soil carbon. It's just a total transformation of how a site operates.
So here is our architect's blueprint for today's explainer. Number 1, the stakes. Number 2, sector analysis explained. Number 3, mitigating wildfire vectors. Number 4, harvesting water on slopes. And finally, number 5, synthesizing resilient systems. Okay, moving right into section 2, sector analysis explained, mapping the uncontrollable. Look, the absolute worst mistake a designer can make is treating a property like it's a blank piece of paper. It is absolutely not. Through this incredible process called sector analysis, we identify and map the wild, uncontrollable external energy vectors that are sweeping across the site from the outside. So we're looking at things like the seasonal arcs of the summer and winter sun, dominant wind roses, the paths of local wildlife, and of course, those critical wildfire vectors. Sector analysis basically empowers you to position the elements of your design to either block, channel, or completely allow these wild energies to pass through unimpeded. Now, what's really fascinating about this breakdown here is how we can systematically categorize these external energies. Notice how we start flipping the script, turning environmental threats into direct design assets. If our threat is intense, arid heat from the sun, our strategy isn't just to hide indoors, right? It's to strategically place biological or architectural shade to regulate that thermal mass. If the threat is flash flooding, we don't just try to drain the water away as fast as possible. We actively collect and spread it. We are literally assigning a tactical job to every single threat that crosses our property line. Section 3. Mitigating wildfire vectors, defending the wildland-urban interface. Designing defensively against wildfire requires a super deep understanding of the fire behavior triangle, which essentially dictates exactly how a fire is going to move. First up, topography. Fire moves rapidly uphill because hot, rising air preheats and dries the terrain right above it, while narrow canyons act exactly like chimneys, accelerating the wind. Second is weather. We have to track those hot downslope winds, like the Santa Ana or Chinook winds, which can transport live embers for literally miles. And finally, fuel. This is the physical medium of combustion, and here is the single most important takeaway for us. Fuel is the absolute only side of this triangle that you, as a landscape designer, can directly manipulate. Because we can only control that fuel aspect, we have to rethink our vegetation entirely. Take a look at the dangerous ladder fuels on the left side here. This is a vertical arrangement of dry grasses, dead lower branches, and shrubs that basically act as a ladder, allowing a simple ground fire to climb straight up into the forest canopy. That's what creates an unstoppable, incredibly destructive crown fire. We absolutely must eliminate these. And on the right, you see what we replace them with: defensively designed hydric buffers and multi-layered shelter belts. These are deliberately placed, moisture-rich zones on the incoming fire sector we mapped out earlier, and they actively block and extinguish those incoming fire vectors. Moving on to Section 4, harvesting water on slopes. Low-impact topographical interventions.
I absolutely love this sketch because it brilliantly illustrates the true elegance of this kind of hydrological engineering. What you're looking at is a cross-section of low-impact topographical interventions. Notice these human-scale, almost watercolor-style rock structures strategically placed directly into the topography. We aren't pouring massive, disruptive concrete dams here. Instead, we're reading the key line of the landscape and placing these porous, natural speed bumps exactly where the water naturally wants to channel and accelerate.
The overall goal of these structures is remarkably simple yet profoundly effective. It's a 1-2-3 punch. First, they slow the surface flow of water. By dropping that velocity, we completely prevent severe gully and headcut erosion. Second, as that water slows down, it drops its sediment and nutrients right behind the structure, which physically rebuilds the eroded soil layer. And third, they force the water to spread out and sink deeply into the earth. Over time, that recruits new vegetation and actually raises the local water table. Here you can clearly see the practical difference between two of our absolute most critical tools. On the left, we've got media lunas. These are crescent-shaped rock structures built on relatively flat contours. Their main job is to take concentrated runoff and spread that water out into a wide sheet to support upland vegetation. Then on the right, we have a one-rock dam. These are constructed specifically inside existing steep drainage channels and gullies. Their primary mission is to stop headcuts right in their tracks and heal active erosion by catching sediment right in the belly of the flow. Together with similar structures, like Zuni bowls, these are just essential tools for healing an eroded landscape. Finally, Section 5, Synthesizing Resilient Systems, the architect's masterpiece.
The true beauty of this entire methodology is that it scales globally. I mean, whether you're studying Sepp Holzer's incredible compiling of pond placements to create more microclimates on the freezing, steep alpine slopes of Austria, or you're integrating contour catchments to grow lush food forests in the bone-dry deserts of Jordan, or even mitigating erosion in the dryland, wildland, urban interfaces of New Mexico, the underlying principle is exactly the same everywhere on Earth, manipulating topography to manage energy. So, to create your own resilient landscape, your final blueprint has to synthesize all these elements. You don't just pick one, you layer them. You start by mapping all your vectors. Then you step in with your earthworks, constructing those one-rock dams and steep drainages, and using media lunas to spread that saved water directly to your vegetation. That vegetation then grows to form your layered shelter belts to block brutal winter winds and your hydric buffers on your fire sectors. Finally, you integrate pond placements. Those serve double duty, providing crucial thermal mass for the soil and acting as a massive defensive water supply against fire. It all weaves together into one unified, impenetrable defense against extreme external energies.
So, as we wrap up this explainer, I'm leaving you with a challenge. Go apply the very first principle of permaculture: observe and interact. Walk outside today, observe the topography of your land. Map exactly where the wind howls and where the water flows, and start creating. Seriously, how will you transform your site's greatest environmental threats into its most powerful assets?